So that is our learning goal for today. We're going to classify triangles based on their sides and angle measures and apply the relationship between interior and exterior angles. So, what is the definition of a scalene triangle?
Oh, I know.
Ellen?
A triangle where all the sides are unequal length.
Yes. So write that down for the first box. All three sides are not equal. Or different. I don't know where to put my notes. Not that I need them, but they might be helpful. Here we go. Okay, what about isosceles triangle? Grayson? Yeah, so there's actually this funny definition for isosceles triangles. It's at least two congruent sides. At least two congruent sides. So that implies that an isosceles triangle can be equilateral, as you see with the one shown. So this is no congruent sides and at least two congruent sides. Now, if we're trying to say the most specific classification for a triangle and you see that all sides are congruent, you're going to call it equilateral. Okay, so this is all three sides congruent. All right. And then that's based off of the side lengths. And then we can classify triangles based off of the angle measures. So you have acute triangle, a right triangle, or an obtuse triangle. Emma? Yes, all angles are acute. So three acute angles. If one of them is obtuse, like if one of them is greater than 90, then it's an obtuse triangle. So one obtuse angle. Can a triangle have more than one obtuse angle? No. I think you probably know if they're both greater than 90, then that would be greater than 180, and a triangle's angle measures can only be 180. And then you know the right triangle is one right angle, which you can prove if you know the side lengths. You can use the Pythagorean theorem. If you have a coordinate plane and you have coordinates for it, you can find the slope and prove that the two sides are perpendicular. Alex? What box?
Box. Right there. On the right triangle.
I don't know. It keeps doing that. It keeps making these like blue boxes as I'm typing.
On the right triangle.
Oh, I'm sorry. Yeah, yep. If you see that, then that signifies that it's a right triangle. Okay, also in the angle measures, so if this is 15, that's 40, then you only have 90 left, so that has to be 90 degrees to equal 180 for all three of them. Okay, and then an equilateral triangle is when all three angles are congruent. This says 60, 60, and 60. Will they always be 60, or can they be other angle measures to be equilateral? Yeah, because if they're all the same, then let's call them all x. So 180 is equal to 3x, and 180 divided by 3 is 60. So in equilateral triangles will always have 60-degree angles. Now, if one of them is 60 and you don't know the others, that doesn't mean that it's equilateral. If you know two of the angles are 60, then the third one has to be 60, so it's equilateral. All right. So next we're going to classify based off of the sides. So number 1. Camden? Yep. Now we have to learn how to spell isosceles. There's only one C, and it's in the middle. And there is no E at the end. Okay? Don't mess it up.
You mess it up when you get.
Okay, number 2. What would number 2 be? Gavin? Yes. It's an accident. Number 3, classify it by its angles. Kendall? Yep, that's a right triangle. See how easy this lesson is? I told you guys. Number 4. Alex? Obtuse. Yes. And obtuse is spelled with an S, not a C.
Gavin, you got that?
Exterior angle. So we talked a little bit about this when we were doing the test review. An exterior angle are angles formed, an angle formed by extending the sides. Shh. An angle formed by extending the sides. And it forms a linear pair with an interior angle. So forms, this is a semicolon, forms a linear pair with an interior angle. So examples here would be angle 9, 10, and 11. Let's keep extending the sides. So I'm going to extend this side this way, this side this way, and this side this way. And I'm going to call this, let's say 12, 2, and 1. Are 12, 2, and 1 also exterior angles? Yes, because they do form a linear pair with 8, 7, and 6, just from the other side. So angle 12, angle 2, and angle 1. Let's add in 3 more. Let's say X, Y, and Z. Are X, Y, and Z exterior angles? No, because they don't form a linear pair with an interior angle. They are vertical to an interior angle. They have to form a linear pair with an interior angle. So they have to form a line. So in parentheses, write not X, Y, or Z. An interior angle are the 3 angles that form the triangle. So 3 angles that form the triangle. So this is angle 6, angle 7, and angle 8. And then remote interior angles are, I'm going to actually type this one out. So this is actually a really important definition that you need to know. Are the 2 non-adjacent angles of an exterior angle. Okay, so let's give an example starting with angle 9. What would angle 9's remote interior angles be? It has 2 of them. The non-adjacent angles of angle 9. But that are interior. It has to be an interior angle. Raylan?
8 and 7.
Yes, angle 8 and 7. Okay. So then if you look, and also angle 1. So it's angle 9 and angle 1. Because angle 1 is also linear pair with 6, so 8 and 9 are the non-adjacent angles. So 1 is adjacent with 6, but not 8 and 9. I'm sorry, yeah, 8 and 7. I do mean 8 and 7. No, 1 is not. Z is. The x, y's, and z's are vertical angles. 1 is an exterior angle because it's a linear pair with 6. It is an exterior angle, yes. Okay, let's do angle 2 and angle 10.
What do you mean by the non-adjacent?
Well, adjacent means next to it, so the two angles that are not next to it. Okay, so 2 and 10 would be 6 and 8. So angle 6 and angle 8 would be remote interior to both angle 2 and 10. And then if we looked at angle 11 and angle 12, both of those have the same remote interior angles, which would be angle 6 and 7. I did not do anything. These notes have existed far before that joke existed. So. Not as a joke. I don't know what it is. It's some weird obsession that you guys have with two numbers. Sully.
Just to make sure, so 2 and 10 are 6 and 8 because
They're not equal to 6 and 8. Well, more on that in a minute. The remote interior angles to angle 2 and 10 are 6 and 8 because they're non-adjacent to 6 and 8 to 2 and 10. Okay, next, some theorems. So the triangle sum theorem says that the sum of 3 interior angles of a triangle add to 180. So the sum of 3 interior angles of a triangle add to 180. This is something that you know, but there's a theorem and it's called the triangle sum theorem. So if we call this, let's say x, y, and z, x plus y plus z is equal to 180 degrees. The exterior angle theorem is related to the remote interior angle. So I'm going to type this one. So this says that the measure of the exterior angle equals the sum of the two remote interior angles. So the measure of the exterior angle, so angle 3, is equal to the measure of the two remote interior angles, 1 and 2. And the reason is because if you know that these two, if you want to find this angle, you would take these two angles and subtract from 180, right? But then if you want to find this angle again, the outside, the exterior angle, you would subtract that from 180 because it's a linear pair. So you can shortcut it by just saying that this angle here is equal to the two remote interior angles. So x is equal to 55 plus 60, which would be 115. Yes?
What is remote?
Oh, that's supposed to say remote.
Interior angle.
Remote.
That bottom one looks very dreadful.
Remote interior angles.
Oh my god.
Okay. Everybody say corollary. The corollary of the triangle sum theorem is the opposite. So, or not the opposite, but it's an extension of it. A corollary is like an extension of a theorem. So this is specific to a right triangle, and it says that the acute angles of a right triangle are complementary. So the acute, oops, make that smaller. The acute angles of a right triangle are complementary, as you know, because they have to add up to 90 degrees.
Oh, that one was easy.
Yeah.
Oh,
Yeah, so easy. So easy.
There's a set extension of
Well, it's called a corollary, so
why?
we call it a corollary. Can I see your notes for a second? Oh, that's cool. Too. Okay. So we're gonna do. All right. So let's keep going. Number 5. Yes.
I have a question about the exterior angle theorem. Why is x equal to 55 plus 6?
Okay. Let's say you want to find x, right? Well, then give it back. Okay. So let's say you want to find x. In order to find x, you would have to know what this angle is. So how would you find that angle? So you would do 180 minus 115, because that's what 55 and 60 are equal to, right? And that is what? 65 degrees? Okay, so once you get that, then how do you find x? You take 180, subtract 65, which gets you back to 115. So it's just less steps. And sometimes these will be expressions and you won't be able to find what this is. So you will have to use the triangle or the exterior angle theorem to solve for the exterior angle. All right, moving along, number 5. So y is an exterior angle and the two remote interior angles are 70 and 88. So we can just add those together. It seems simple now, but make sure that you don't forget this concept later or misapply it. So apply it in a situation where it doesn't work because the angle isn't exterior or the angles you have are remote interior. But this would be 158. Number 6. So we know that those two angles have to be equal to 90. So 2x plus equals 90 because of the corollary of the triangle sum theorem. So x is equal to what? 45. Probably didn't need an equation to set that up, but that's the equation if you did want one. Okay, the explanation points are just degrees. It's okay. So it says 70 degrees, 30 degrees. Let's find the measure of angle 2. 1, I mean. What's the measure of angle 1? Grayson. 60 degrees, yes. How about measure of angle 2? Gabby? Yes, let's raise our hands. And then measure of angle 3? Colton? 88 degrees, yes. Good job. That was easy. Well, you know how this is 70 and 30 for this triangle? So they have to add up to 180, right? It's already 100. Number 8. In triangle ABC, A equals B plus 30 and C equals B plus 60. Find the measure of each angle. So let's draw it out. We've got A, B, and C. Sometimes with these, I like to replace the variable with an x. So if angle B is x, then angle A would be what? X plus 30, and angle C would be x plus 60. So if we add those up and set them equal to 180, we can solve for what x is. So x plus x plus x, you've got 3 x's, so 3x plus 90 equals 180. Subtract the 90 over and get 90, divide by 3, and you get that x is 30. So the measure of angle B is 30. The measure of angle A is 60. And the measure of angle C is 90. Grayson?
How would be less than A? Oh, wait, never mind. I see it now. I read it.
Oh my god.
Gavin?
You ruin everything.
Okay. Number 9.
Gavin, don't.
Okay, what's the measure of angle 1? Maybe I should pull some sticks for this.
I can do it.
Arian, 70 degrees.
So what do you do for the x equals 3?
Well, you plug it back into the other expressions for A and C.
Oh.
Okay, so if that's 70, what's the measure of angle 2? Gabby? You said 75? You sure about that? It'd be 65. Because if this is 45 and 65 and that's 70, then angle 2 would have to be 65 too.
So you got 70.
And then the measure of angle 3. Raylan?
105.
Are you sure about that?
So that'd be 95. Never mind. I do that.
Yeah, 95.
Wow. What are you doing, Joe?
And we have plenty of time for the proofs. All right. So we have options at the top. Number 1, let's go ahead and write. Actually, we're not going to write what we're given. That's actually not an option because it just says we're given the triangle. So there's this method that sometimes you can use. You can add in a line that you can call parallel to another line. So right now you see line BD is parallel to AC. We drew that in to help us with proving that angle 1, 2, and 3 equal 180. So you're trying to prove the triangle sum theorem here. We can write down what we're trying to prove, right? So where is that? Right here. So I'm going to cross this off and put that down at the last step. So 1, 2, 3, 4, and 5. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. I just don't know the reason yet. Okay, but the first step is going to be the trick that they're doing. They're drawing a line parallel to AC. They're adding a line. So it's this one. So draw line BD parallel to line AC. So draw line BD parallel to segment AC. Well, what this is called is the parallel postulate. Okay, don't worry about that too much right now.
Givens don't have to be like the first thing, you know.
Well, we're not going to put the given because we're just given a triangle. We're not really given anything except this triangle.
There is no given.
Yes, shh, yes, we understand. So the parallel postulate, so you can cross that off. Okay, now that we know that BD is parallel to AC, what else do you suppose we could say next? Arian? Wait, you did the 4 plus 2 plus 5? That's okay. Yeah, we could say that next. Yeah, it does it. We could say it out of order. There's different orders that you can write what's next. I keep pressing button. So the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180. And what's the reason? Arian? Do you see which one goes with the reason? Let's phone a friend, Camden.
It's like
Which one do you think goes with that?
I'm trying to. I don't really know what it would be called, but I know
Well,
it's
just
something.
you gotta look at your options. You have options at the top. Ellen? Yes, it's this one. So angle addition postulate and definition of a straight angle. Just combine them together. Okay, so angle addition postulate. What the heck? Postulate definition of a straight angle is 180. It's okay. I mean, it's a straight angle, right? It's It's like a linear pair. Yeah. It's okay. And then number 3. What can we say for number 3? Gavin.
You could say m plus 4. Wait, hold on. You could say wait, you could say 1 is 2, 1 is 4, 2 is 3, 2 is 5.
Yes. Yes. Yep. That's what we're gonna say, and that's because of the alternate interior angle theorem. And then next, we're going to say that the measures, convert that to measures being equal so that we can make a substitution. So the measure of angle 1 equals the measure of angle 4, and the measure of angle 3 equals the measure of angle 5. So definition of congruent angles. And then finally, you can substitute in here 4 with 1 and then 5 with 3. So you prove that angle 1 plus 2 plus 3 is 180. So substitution for the last one. And then on the next page, we have another proof here. It says, given another triangle, we're going to prove the triangle exterior angle theorem. So let's write what we're trying to prove, which is the measure of angle 1, which is BCD equals the measure of angle A plus B. So it's actually this one here at the top is what we're trying to prove. So the measure of angle BCD equals the measure of angle A plus the measure of angle B. And so for number 1, what do you want to say? Which one of these should we use? Hint, we now have proven the triangle sum theorem, so we can use it in proofs. Raylan?
Measure of angle A is measure of angle B is measure of angle A plus B.
Yes, that one. The triangle sum theorem one. Measure of angle A plus measure of angle B. Notice they're not saying measure of angle C because C is the vertex of more than one angle. You have to say measure of angle ACB. You have to specify the 3 angles, the 3 vertices of that angle, and that is the triangle sum theorem.
Why do you need to prove it? Like, all triangles.
Because we're in geometry and we're proving the theorems.
But it's always 180.
Yes, because it's a theorem that we proved.
Why wouldn't it be a postulate?
I don't know, Alex. I don't make up the rules. Okay, number 2. What can we say next? Let's see. You've got transitive property. Probably not ready to say transitive property yet. Linear pair postulate and definition of supplementary angles. Can we use that? Let's see. This says shh. ACB plus BCD equals, we're probably not ready to say this, right? Can we say this up here? What's this say? ACB plus BCD is 180. Can we say that right now? Yeah. And that would be linear pair postulate and definition of supplementary angles. So we're going to put measure of angle ACB plus the measure of angle BCD equals 180. I'm just going to say linear pair postulate and slash supplementary angles. And then we can use the transitive property. Okay, so this is a hint for people who haven't taken the test yet and a review for people who have. If 2 things are equal to 180, you set them equal to each other, right? If 2 things are equal to 180, you set them equal to each other. That's substitution or transitive property. Okay, so next, since they're both equal to 180, this is equal to 180, I forgot to write it, we're going to set them equal to each other. So this is going to be equal to this, okay? So measure of angle ACB plus measure of angle BCD equals measure of angle A plus measure of angle B plus measure of angle ACB. And that is transitive property. Then, also another review from the quiz. If you've got two things on the same side, you can subtract them out, right? So what do you see is the same on both sides that we can subtract out? Emma. Yes, ACB. ACB. And now it's equal to BCD equals A plus B, which is the triangle exterior angle theorem. So step 4 is subtraction.
Traction.
Oh,
Oh.
we understand.
Okay.
Fine, though.
And we're going to save the exit ticket for Monday.
Are we even doing any homework?
No homework.
Are we getting new seats?
Eventually. Yes.
No,